Hi, my name is Keita. Today, my group and I will present to you our team project, which is the development of human activity recognition using MobileNet convolutional neural network. Before we get down to what we have done for the project, I would like to briefly introduce our team members. Our team has 7 very dedicated members, including Yvonne, Minjung, Maureen, Sylvia, Ephraim, Ronald, and myself, Keita. We have been working very hard for this project, and now we are so proud to show you what we have done. First of all, I would like you to have a look at what we have on the screen right here. This one is actually an infringement notice that I received back in 2019 when I was in Australia because I was using my mobile phone when I was driving on the road. And of course, I wasn't particularly happy when I received this one. However, I was so fascinated to know that there was a mounted camera on the road and it took picture of me and it could actually determine whether or not I was using a mobile phone. That was really surprising to me. So I had to look into it. And that was what I found. This piece of technology enabled by AI is introduced by a Australian-based company, and the system automatically takes pictures of every passing cars, comb through each and every single one of them, and identify whether the person is actually committing the offense of distracted driving, which is using mobile phone when driving. That is also the idea behind our project. We are so keen to explore and gain a better understanding about the human, activity recognition and the process of machine learning and the different machine learning system behind the work. That's why we have this project. Human activity recognition, and the convolutional neural network. So I've just mentioned human activity recognition, also known as HAR. So what is it? By definition, it is a process of interpreting the motion of human. The motion of human can actually be understood as gestures, activities, and behaviors, which are taken by cameras or recording sensors, which are then translated into action commands for computers to execute, analyze, all of the human activity recognition code. And why this one is a big deal nowadays, because it is actually has been used in many different sectors of the economy, industries. It can help in automation and eliminate the involvement of human labor, just like in the case of mobile phone use and detection camera that we've just mentioned earlier. Everything was done automatic, and behind these processes is actually the convolutional neural network. So what is the convolutional neural network? It's actually a class of deep learning, and it is extremely popular and a breakthrough in image processing, analyzing, and classification. Very fast and highly efficient. How it works can be understood through this diagram right here. So for the purpose of illustration, you can look over here. On this end, we have a set of different images of vehicles. Each has a predefined class, say cars, trucks, vans, or bicycle. And the CNN network, which is the convolutional neural network, has 4 basic components, including the convolutional layers, the ReLU layers, the pooling layers, and a fully connected layers. This system will learn from this data set. We take the image input and we'll assign importance, by which I mean, like the learnable weights or the biases to the aspect of these images. And it will help to process, classifies, and predict the class of the image. So say we introduce a new image, like feed the system with a new image of a bicycle, the system can actually differentiate one image from another and can actually accurately classify the image into the right class. So that's a very vague understanding of how the CNN work. I'm going to pass on to Sylvia, who will be introducing to you about the MobileNet model, which is a CNN architecture.
So for the literature review, we're going to be talking more about the MobileNet and the CNN architecture that we used for our research. So we worked with 4 authors, mostly Howard, Quinn et al., Su et al., and Kasogi et al. And most of them had one or almost the same thinking about the MobileNet and the CNN architecture. A major part of their definition was the fact that the convolutional network are frequently used as convolutional layers. MobileNet is a CNN architecture that is much faster, as well as smaller model that makes use of a kind of convolutional layer known as depth-wise separable convolution. Because of the small size of this model, these models are considered very useful to be implemented on mobile and embedded devices, hence the name MobileNet. They also agree that MobileNet is good for mobile and embedded vision applications, and that is what MobileNet is proposed for, which are based on streamlined architecture that uses depth-wise separable convolutions to build lightweight deep neural networks, which are two simple global parameters that are efficiently trade-off between latency and accuracy as introduced. Thank you.
MobileNet model is a tensor-first mobile computer vision model, a class of lightweight, smaller, and faster deep CNN that was open sourced by Google. It's designed to use in mobile application browser that is named MobileNet. The speed and power consumption of network is proportional to the number of MAC multiply accumulates, which is a measure of number of views, multiplication, and addition application. In this graph, we can see another popular model like VGG16 that has higher MAC, means higher power consumption compared to MobileNet, with a relative smaller accuracy differences. MobileNet has smaller size compared to VGG16 due to less number of parameters. MobileNet is used for object detection like in Tesla, fine-grained classification to extract single image from an image with cluster background, face attribute in video surveillance and criminal investigation, landmark recognition as in Google Maps. MobileNet uses deep-wise separable convolution that significantly reduce the number of parameters when compared to the network with regular convolution with the same depth in the nets. The result, lightweight deep neural networks. Deepwise separable convolution filter are composed by deepwise convolution filter perform a single convolution on each input channel. Point convolution filter combined with the output of deepwise convolution linearly by one convolution and pointwise convolution. The key distinction between MobileNet design and the conventional CNN, that is the former uses batch normalization and reloop after 3x3 convolution, while the MobileNet we use 3x3 deepwise convolution and 1x1 convolution. This is what we do. We feed the image into the system and convert into numerical value, and the numerical value fed to the system. We separate training set and test set. Data modeling phase, we train our data with MobileNet model and save best weight with the highest accuracy in 50 epochs. After training, we load the model to get the weight and use predict to evaluate training process. We can use the weight to further improve the accuracy of our model.
Thank you, Yvonne. Hello, you guys. I'm Minjun Kim. I will explain dataset human activities. As you can see, there are many images. The purpose of this dataset is to identify human behavior by computer. Unfortunately, there are countless tasks that human can perform, so it's impossible to cover them all. Therefore, among them, 15 types of routine tasks were prepared. As you can see, calling, clapping, cycling, lapping, so on. We have a structured data set split into train and test, each containing 12,600 images of 15 classes of actions. And then we created a CNN model, take an image, input and predict amongst the 15 classes. After that, we will trial of our team members' actions. Next, Leonard will explain approach, result, and accuracy. Thank you.
Basically, how we develop our human recognition model is that we have done a transfer learning from using one of the curious picturing model called MobileNet. And as mentioned earlier, we have a bunch of images that belong to 15 different labels. Among all of those images, we have reserved 15% of them for the testing part. And in the 85% of the images, we also assign 20% of them for doing the validation during training. And on the slide, here is a conceptual map showing how the process goes. First of all, the model that we compile, it extract the features from the image with the predefined labels. The model will do all the learnings. After the training, it will develop the algorithm to classify those images to the corresponding labels. And then moving on to the testing part, we fit a new whole set of images to the model, and the model will start extracting the features from the image again. And with the algorithm that is already developed in the training part, the model will start classify the images to the corresponding label and do the prediction. And in our training, we have 150 epochs. After a very long period of time, we finally have our model being trained, and here the stat from the training process. Actually, this is a very good sign from the training result, because you can see that the loss was actually decreasing while the accuracy was actually increasing. It means that we are actually heading to the right spot, leading us to the right direction, at least. And moving on to the testing part, we have fit our model to all those testing images, and what we got from there is that we have a 74% of accuracy, which is actually not bad, because beside MobileNet, we have done another transfer learning from another pre-trained model called VGG16, and the result we have got from there was only 66%. And that is the reason that why we are settled on using MobileNet as our transfer learning model. Actually, to better illustrate the testing result, we can pull up a confusion matrix to illustrate the whole result. But for those who don't know what a confusion matrix is, it can somehow do best, which is to confuse you. Simply saying what we have got from here, we'll just use a heat map to present our confusion matrix for the better visualization sake. And what we can see here is that at a glance, we can see that the deep color boxes are being formed as a diagonal line from top left to bottom right. It actually means that our model can somehow generate a reasonable amount of true positive result. So this is actually a good sign. And for here, what we have, for example, for cycling, actual image is on Y and predicted label is on X. What we have for cycling is that we have a 98% of accuracy from there, and it actually means that our model can predict 98% of the cycling images correctly to the cycling label. And here are some random samples. Here a random sample of testing. So you can see that we have 9 images here from the calling label, and our model that time it can actually had 6 hit, which is not bad, the result. And then moving on, thanks for Yvonne for dedicating herself to our training process. We have a bunch of images of Yvonne doing different things, and our model can actually recognize what she was doing at the time. So basically, we can say it here, our model was actually working and practical. So moving on, we will talk about how we are going to use our model in a practical usage, and Mo is going to walk you through on this.
So this application or this model can also apply to real world. In crime detection and prevention, video surveillance is now very important for public safety. And as well as governments typically deploy CCTV cameras to monitor crowd behavior in order to preserve public safety. However, while cameras generate a large amount of data or visual, we require an intelligent and automatic system to detect violent or suspicious activity. This is where the motion tracking comes in, or this model comes in. Second one would be this can help the disabled or in the industry of medical with a inline and streamline with telehealth. So human health has also a benefit from 3D human body postures. Thus, this technology has the potential to be utilized in telehealth. For example, a doctor will be able to do their checkups or do quantitative motor examinations immediately in a patient zone it's because of a virtual meetup. Recognizing unusual behavior is also vital for autism identification, since early discovery is very critical to improving the person's life. So overall motion tracking may determine people mental states as well as their emotional well-being. Thank you.
Hello, everyone. This is Ephraim Cañete, and today we will discuss in this particular section about our demo. Let's first go to our code. Our code structure is divided into three different phases of our data science project. The first one is the data preparation, where we load our data set in the libraries and we prepare our data. The second part is our data modeling, wherein we compile our model, save our model, and then we load our model and weights. The last part of our data science process is our data evaluation, where we make a prediction and we will show our prediction. Let's go to the code. So here we will build the confusion matrix and show you what's accuracy of our model. And then we will run our show prediction behavior so that you can see that it specifies if the picture is sitting, if it's calling, if it's using a laptop, and it's calling. So far, it classifies our 6 out of 9 in our prediction. And in the confusion matrix shows also the accuracy for the different classes. Now, we will show you also that we created sample for new dataset that we have. It will show a sample for our dataset. This is a new image that's not from our dataset. Like Yvonne drinking, Yvonne in a different dataset that we have. Okay, and eating. Oh, wait. Okay, let's run that, list the different images that we want to predict, and let's show the prediction. So after running, you can see that our model has predicted the different behaviors. So let's start from the first image. So it appears that when Yvonne is drinking, our image wrongly classified that as using laptop. When it's drinking, classifies that as well as drinking, and also this drinking image. Another is when Yvonne is eating, so our model wrongly classified it as drinking, because anything that's related to mouth, I think our model is classifying that as drinking. This is another eating, which wrongly classified as drinking, and another. And the last one is when Yvonne is laughing, so the model correctly identifies. So anything with a smile is a laughing classification for our model. So that's part of our demo. And for our last demo, we have a picture of our group. Let's see how our model understand that. So, all right. So thank you so much for your time. If you have questions, let us know. These are our reference materials that we used in our presentation. Thank you. Have a great day.